Okay, this is chapter 3, sequences and series. We're going to start off with arithmetic sequences. So an arithmetic sequence is when we have some numbers, typically separated by commas sometimes, and the numbers are going up a little bit like this. Okay, you would have known it by a linear sequence up to now, but we're calling it an arithmetic. So we're going to answer this slightly differently to how you would have seen at GCSE. So we're going to call the first term A. We're going to talk about the difference this time. So the difference here is +5, for example. We're going to call this part D. And we're still going to use N to talk about the number of terms. So for example, here, N is 4. It means it's the fourth term. The next part of the sequence, which would be 23, that would be when N is equal to 5. Okay, so A, D, and N, you're going to hear me refer to. A, D, and N. Okay. And the main rule we're going to be using is that if you want to work out a term, let's call it the nth term, meaning if you tell me a position, so if you say the fourth term, okay, when n is 4, there is a rule that we can use. And the rule is as follows. You take the first term and you add on the difference n minus 1 times. And I'll just show you again very quickly that this is pretty intuitive. Okay, so if this is the first term, this is called A, right? So how do you get to the next term? Well, you add on the difference. The next term, you add on the difference twice, and so on and so on. Okay, and if you remember that n refers to the position, so this is the first position, the second position, the third position, the fourth, and so on, you'll spot a basic pattern, which is that the value for n and how many differences there are, well, they seem to be, the differences seem to be one behind. So like from the third term, you have 2 differences. On the fourth term, you have 3 differences. So that's where this part comes from. Okay, on the fourth term, for example, you have the difference 3 times. That's why it looks the way that it does. And let's answer the question now. So an arithmetic sequence has a first term of 80. So the A is 80. The common difference, the sign is important, is -16. Write down and simplify an expression for the nth term. Well, all you would say is the nth term. So we use the rule is 80 plus n minus 1 times, I'm going to put the -16 in brackets because that tends to cause problems. And you could just expand that out if you wanted to. Okay, but typically the way it's written there is the way we're going to use it. So let's practice that a little bit more. So a boy saves some money over a period of 60 weeks. So that might be important. He saves 10p, 15p, 20p. Okay, so I can say then that this is an arithmetic sequence because adding 5 pence, that seems to be the difference. And it seems to be common, as in the difference is always the same. He saved 10p in the first week. That's an important piece of information as well. So the first term is 10. The difference is 5. Now, depending on what the question says, I should be able to work out whatever I need to. So for how much does he save in week 15? In other words, when n is 15? Well, the nth term is A plus n minus 1 times the difference. Okay, in particular, the what's this? This is the 15th term must be equal to 10 plus, you could call that 14 if you like, 14 lots of the difference 5. So the amount that he saves in the 15th week is 10 plus 14 times 5, which should be 80 pence. Okay, you do not want to be adding the number 5 14 times. Why don't you want to be doing that? Well, number one, it's going to take you too long. You might make a mistake. And actually, isn't that what you're doing with this formula anyway? It's just trying to take that idea and make it easier. So 80 pence in week 15. Let's try a more difficult one. So the 14th term of an arithmetic progression sequence is 101. The 18th term is 133. Work out the 5th term. So I'll show you two ways you could answer this. So the more general approach would be like this. The 14th term is equal to a plus, well, n minus 1 means it's going to be 13. So it'll be equal to 13 differences. Okay. And I know what the 14th term is. It's 101. So I could substitute that in. How about the 18th term? So the 18th term is going to be equal to a plus n minus 1. That's 17. 17 d. And we know what the 18th term is. It's 133. Now, if you subtract equation 1 from equation 2, so in other words, if you do this, the a's would cancel. You'd get 133 minus 101, so that's the same as 33 minus 1, so that's the same as 32. And you would get 17d take away 13d, which is 4d. Okay, so 16, 8. So in other words, 8 is the difference. Okay. You also then could use the difference again, because it's always the same. It has a common difference. You could substitute that back. So for example, you could substitute that back here. Okay. And what would that do? It would give you a new equation, which would be 101 equals a plus, what we're doing here, 13 times 8, which is 104. Move that to the other side. It tells you then that a is equal to minus 3. So why is this good? Well, now you know what a is and you know what d is. You can work out, say, the 5th term. You know that the 5th term means a plus n minus 1 is 4. 4 lots of the difference. So it must be minus 3 plus 4 lots of 8. Okay, which is 32 minus 3, which is 29. Okay, so that's one way that you could have done it. If the terms are very close together, there is a slightly different way you could do it, which is you can just count it out. So the 14th is 101, then there's the 15th, then there's the 16th, then there's the 17th, and then there's the 18th. 1, 2, 3, 4. So 4 differences must take you from 101 to 133. Okay, and I could get straight to that line of working out. This method only works well if the terms are close together. Otherwise, I'm afraid it's just a bit too slow. So there you go. This one here really is probably the most common type of question that you're going to encounter at the start of this chapter. Right, we're going to do one more, a wordy one. So each year Andy saves in year 1. So that's important because that means that's your A value. He pays £600. They increase by £120 each year. So that's the value for D. So that he pays 720, 840. Yep. We know that. That's just making it clear what's going on. How much does he pay into the scheme in year 10? So when n is 10, how much? Well, the 10th term is a plus n minus 1. So that's going to be 9 here, 9d. So it's going to be equal to 600 plus 9 lots of 120. And the answer for that is going to be 600 plus 9 lots of 120, £1,680. Okay, that's all we need to do. So we're going to move on to the next part then. So part B, which is a bit more difficult. So up until now, we've been talking about sequences. So I'll give you a very, very basic sequence here, which could just be, say, for example, the numbers from 1 to 10. Okay, so here's what I want to do now. I want to move from a sequence to talking about a series. So how do I do that? Well, this is a series. A series is when you have lots of different parts and you decide now that you're going to add those parts together. Okay. Now, we don't want to be doing this on a calculator because it's going to take us too long. And we might be forced to use these approaches anyway. So I want you to think of doing something a little bit different. Let's instead think about pairs. So I'd like you to pair up 1 and 10 and add those together. I'd then like you to take 2 and 9 and add those together. Now 3 and 8. Now 4 and 7. And now 5 and 6. So what do you notice? You notice that they all add up to 11. And you notice that there's how many pairs there? Well, there were 5 pairs of it. So the answer is 55. So can we use this kind of strategy a little bit more quickly, a little bit more generally to add the numbers? Well, yes, we can. So let's imagine now that the first part of the sequence is A. The next part is A plus D. The next part is A plus 2D. And so on and so on, okay? And we're going to keep this going for quite a long time until the nth term. So you actually know what the nth term is. That's what the rule was from before. So A plus n minus 1d. Okay, that's the nth term. Well, what were we just doing? We were pairing them up. We were pairing a number at the start and a number at the end. We were adding them together. If you do that, you'll notice that you get 2a, and then you get the n minus 1d part. Okay? Now, when you pair up the next bit, don't worry if this is a bit much right now, but when you add this one and the term before, you can't actually see the term before, so let me just write the term before so you can see it. That would be a plus n minus 2d. Well, when you add those together, you'll actually get exactly the same result again. Okay, you'll get 2a plus n minus 1d. So you're going to get this result how many times? Well, when we did it with 10 numbers, we got the result 5 times. In general, you're going to get this result n over 2 times. So when n was 10, n over 2 was 5. Okay? Because there's pairs, you divide by 2 is the idea. So this rule here is the rule that we need to use when we want to add all the numbers together. It's called a series, okay? And this is written in the formula booklet. But notice, please, that it's just the same again. The first term, the number of terms, and the difference. Those are the pieces that you need. So let's try it. We're going to use this one here now. Right, so we're giving money to charity over a 20-year period from year 1 to year 20 inclusive, giving £150 in year 1. So that would be the A value. 160, 170, etc. So that tells me then that the difference is 10. So it forms an arithmetic sequence. Calculate the total amount of money she gives over 20 years. So n is 20. So this means it's a series question. It wants us to add it. So it wants 150 plus 160 plus 170 and so on. Now you're going to be there a very long time if you're adding that up. Let's use the rule instead. So the rule is n over 2 and then 2a plus n minus 1 times the difference. If we put the numbers in, n should be 20. We get 20 over 2. We get 2 times 150 plus n minus 1. N is 20, so n minus 1 is 19. 19 times 10. And if you put that all in your calculator, so which I'm going to do now, making sure I use brackets nice and carefully, I get 4,900. So if you think about how quickly that works, chances are, even if you added that on your calculator, as soon as I read it out, you wouldn't have done it that quickly. Okay, so we can add all 20 years and we should get £4,900. Final question we're going to do in this is we're going to try a harder one. This is actually quite a common question in the real exam. This came up in 2022, for example, this one here. The first term is 7. Great. A is 7. The difference is 2. Okay. The sum. So the sum would be that part there. Okay. The sum is minus 2,900. Find n. So what we're going to do is we're going to use that formula again. So the sum is n over 2, 2a plus n minus 1 times the difference. And we're going to substitute all the numbers in. And in fact, we'll get some credit for that. So minus 2,900 equals n over 2. So n you don't actually know on this one. 2 times a, so 2 times 7. More generally, this is, well, yeah, I would substitute like this. I'd put all the numbers in because you'll get loads of method marks for doing this, okay? The difference is minus 2. Watch that. That was the most common mistake when I examined a paper with a question like this. The difference had a negative and people forgot to do that. Close the brackets. So what should we do now? Find the value of n. Let's move this 2 up. Let's simplify stuff in this bracket. So minus 5,800 is n. And now we've got 14 in there. So n times minus 2 is minus 2n. Minus 1 times minus 2 is plus 2. So I'm going to write it like that. Okay. I'm now going to expand out the bracket in the next line. So minus 2n squared plus 16n. And I've still got a minus 5,800 here. Okay. Just checking my work. Yep. They're all even numbers. So I'm going to divide it by 2 and I'm going to move everything to the left side at the same time. So n squared, that will be minus 8n if I change it and divide it by 2. And this will be minus 2,900. And that will be equal to 0. I'm now going to use the quadratic solver on my calculator. Make sure you know how to do this if you don't already. So 1 minus 8 minus 2,900. Let's type that in. So I get n equals 58. And if I press the equals button again, I get minus 50. So minus 50, I'm going to write it and then cross it out. It's not valid because it's the number of terms. And we're going to make the restriction. You cannot have a negative number of terms. So there we go. It's 58. And yes, that is in fact 5 marks in the real exam. But that's how we would do it. So sequences. The main rule we were using was a plus n minus 1d. For an arithmetic sequence. And then when we move to a series or a sum, that's when you add the terms together. And that has a different formula, which is in the booklet, which is what we were doing in those last 3 questions.